Welcome to another lecture on multi-chain. In this session, we will understand how to use native assets and transfer them from one node to another node without actually interacting and doing anything on the blockchain. This will be a transaction which we will execute, and the assets will get transferred from one node to another using command line. Naturally, the first thing that comes to our mind is what are assets or native assets, and how are they related to blockchain? The multi-chain blockchain allows the creation and tracking of assets at network level. This is an interesting use case of multi-chain to define native assets and let the peers and nodes transact them in an automated manner or in a non-automated manner. It depends. Now, you might wonder how these assets are represented in the blockchain and what real-life use cases they possess. So it can be literally anything. You can convert anything or count any business entity as an asset. For example, it can be your resources it can be a real currency in the banks, it can be a virtual currency like the Yo-Yo wallet in UK. The money in these mobile wallets, including information about when anyone transfers or receives money, can actually be tracked using blockchain. It could also be a CPU or a virtual currency like Bitcoin. Even a fraction of Bitcoin can be called virtual currency. It depends on business to business how you define your assets. Assets are nothing but a representation of the valuables in a company, which you can transact from one node to another node, or say one address to another address, and make the business use cases of it. For example, in this use case, the logistics company or logistics management company has one consignment which is equal to one asset, and they have a certain node which is defined whenever assets are created. Whenever a new consignment is booked by the company, a new asset is created. Once an asset is created, every branch will have a different server where this asset will be transferred from one server to another server, or one address to another address, which implies that the asset is being transferred from one branch to another independent branch. You can represent a branch using this address. These are the kind of use cases that you can define and create your own. Thereby, whatever you want to build, it's up to you, because the possibilities are endless. In step 1, we need to ensure that we are connected to both the servers. Here it shows that Node 1 as well as Node 2 are connected in the interactive mode. Please switch to interactive mode in case you're not in the interactive mode. Let us begin with the native assets in multi-chain. As mentioned on the multi-chain websites, multi-chain supports assets natively at the blockchain level. The identifiers and the quantities of the assets are encoded within each transaction output, alongside the quantity of the blockchain's native currency, which may be 0 if it is not being used. In simpler words, it means that whenever the inputs are fed, they are actually encoded. Each transaction has input as well as outputs, so whenever assets are shown in the outputs, they are properly encoded. Every multi-chain node tracks and verifies the quantity of the assets in the transaction, just as in native currency. This clearly means that it is very important that the total number of assets in the blockchain should remain the same. No one can create the assets out of thin air until and unless there is a node which has the power to issue assets. These features are available in multi-chain, and only an admin can issue the assets, which means admin is like head office, who are actually allowed to issue the assets. Or another example could be a particular server or a node which will issue the assets only if the cash is received by the company. Transactions are specially monitored when they transfer the native currency from here to there, or when the assets are being transferred from one node to another node. It actually checks the total quantity of all the assets in a transaction output. Hence, there should be perfect harmony in total assets between inputs and outputs. Multi-chain also allows each transaction output to contain different number of assets. You can define 5 different types of assets because let's say for an e-commerce company, you want to have 100,000 products for your company, which will be on sale, and multi-chain allows you to have 100,000 different assets. For every product you buy from the vendor or bring it on board, it will be defined as an asset. For example, You can calculate how many mobile phones you have in your e-commerce system by using assets in the multi-chain. The entire e-commerce industry can be revolutionized on the basis of multi-chain, but because this is a new technology, it will take some time for people to get comfortable with it. In multi-chain, assets can be identified by any of the three ways. First is an optional asset name chosen at the time of instance, which can be saved and encoded strings up to 32 bytes in size, and these are case-sensitive too. Second is the issue transaction ID that acts as an identity of an asset, and the third one is an asset reference, which encodes the block number and the byte offset of the insurance transaction along with the first 2 bytes of the transaction ID. If these three things are merged, then you have an asset reference ID. Later on, I will show you what an asset reference looks like. In case you want to learn more about the assets in multi-chain, you can refer to the multi-chain websites or white paper on multi-chain. Now let us have a look at the permission of Node 1 list to understand who has the issue permission to create assets. Here you can see there is only one address, which means the address is owned by Node 1. This is called as LDFG. Only Node 1 has the right to create assets, and we are aware of this because we ourselves haven't given any asset issuing rights to Node 2. This implies that only Node 1 can initialize assets, create them, and issue them to the system. Since we already know that only Node 1 can issue assets, let's do it practically and see for ourselves. For this, I will use the issue command along with address name. For example, I will issue 1,000 units to myself and call this as asset 1. Next, I will add the command for 1,000 units as well as subdivisions like 0.01 or 0.001. The same way as we have small fractional values in Bitcoin. Therefore, you can see that asset 1 has been issued with 1,000 units to myself along with a transaction ID. Let us now assume you want to check how many assets are available in the system. For this, you can use the list assets command. Once you enter this command, you can see the name of the asset, the issued transaction ID, and how the asset has been recognized. It is clearly evident here that the transaction ID is synonymous to the issued one. After that is asset reference, which tells you how the asset looks like and how it can be represented. After this, we can go ahead and check the status of assets in Node 2, because right now, we added all commands in Node 1 only. Add the list assets command in Node 2. Here you can clearly see that the asset has already been propagated to Node 2. It might look very simple as these screens are located next to each other, but in real time, Node 1 could be in Germany, Node 2 could be in USA, Node 3 in Australia, and Node 4 in Japan. And this is the beauty of multi-chain, that an asset issued using Node 1 in Germany is automatically transmitted to the other nodes in a fraction of a second. Because every node is synced and decentralized, everyone is aware of the information. Now, if you were to shut down the server in Australia, then the functionality of the other nodes in various other parts of the world is not affected, all thanks to decentralization. At present, what is visible are the details of the assets, but not the total balance. Click on Node 1 to check the total balance by using the command getTotalBalances. The result shows that we have asset 1, asset reference, and quantity 1,000. If we use the same command to check Node 2, we see no results because we issued the assets only to Node 1. Next, we will send assets from Node 1 to Node 2. To do this, we need the receiving address of Node 2, which we had copied to our notes earlier. Enter the command sendAsset space node 2 address space, name of the assets, and then whatever quantity you want to transfer. For example, I want to transfer 100 units to Node 2. For that, we have this transaction ID, which means the assets have been transferred. but we will check the same on node 1 by getting total balances. As you can see earlier, it was 1,000 and now it is 900. Next, we will check the total balances on node 2. Here also there is an addition of 100 units, which was earlier nil. This transfer was done easily from one address to another. Hence, Multichain is making it easy for everyone to install and build applications on it. I hope you have understood how we send assets from one address to another. Another thing here we can look at is wallet transaction details. For this, I will check node 2 and execute the command list wallet transactions. This will actually show you a list of transactions that have happened on this wallet, i.e., we received asset 1 from node 1, whose quantity was 100, the sending address, the receiving address, and all other details. Next is confirmation, which shows on how many blocks has the transaction been recorded. It is mandatory for the transaction to be recorded on minimum 1 block only. Then is the transaction confirmed. The block hash has the transaction details and all other recorded information. Similarly, if we check node 1 with the same command, you can see the transaction. Here it is a -100 transaction because they were deducted along with a change in address, whereas in node 2 it was added. If you look here, you can see that the confirmation has increased to 10, and this will keep growing. Next, we will understand how to make a transaction with metadata. When you send or execute a transaction, you can also add some metadata into the transaction. For this, I will send 125 asset units from node 1 to node 2 with metadata. I will use this as a JSON because you can use multiple names and their values in a single transaction, which is an amazing feature of Multichain. In node 1, I will use a send with data command space, the address of the receiving party, i.e., node 2 in this case, and the metadata command, which I'll copy from here and paste in the command. Now that we have transaction ID, it means some asset has been transferred from node 1 to node 2 with metadata. Again, let us check the total balances and you can see it is now 775 units. Next, if I check the list of transactions, you can see that it says -125 along with confirmation, which means it's a confirmed transaction. Repeat the same process for node 2, and here you can see the balance has increased by 125. Go back to node 1 and check the wallet transaction, for which I'm going to copy the transaction ID of the last transfer that was made and execute the command. It shows all the details of the transaction along with metadata that you have sent. Metadata can be of any size. Basically, it's like attaching some extra information while transferring the assets. So that's all about asset transactions and metadata in Multichain. Send us your queries on hello@blockchain-council.org. Thank you.